So the units of Kc depend on the expression for Kc, because different equilibria have different expressions. So if we have a look, first of all, a little bit of maths 101, you should already know that if I multiply x by x, I get to x squared. That's nice and simple. You should know that if I multiply x squared by x squared, essentially I'm saying that's x times x times x times x, which gives me x to the power of 4. Okay, basically, if I take x cubed multiplied by x to the 4, we end up with x to the 7. Basically, what I'm saying here, and this is important for calculating our units, is that if we have terms, the same terms with indices, if we are multiplying them together, we add the indices. So x squared times by x squared gives us 2 plus 2, two indices, that gives us 4x to the 4. Same with the x to the 3 times x to the 4, 3 plus 4 is 7, that gives us x to the 7. Similarly with division, if I take x squared and I divide it by x, that's x times x divided by x, we cancel out the two x's, we end up with just x. If I take x divided by x squared, that's we cancel this out, we get 1 over x. And what you can see here is that we are now subtracting the indices. So 2, that's the numerator on the top, subtract from the indices of the x, that would be x to the 1, wouldn't it? So that's 2 minus 1 is 1, we end up with x to the 1. On the other hand, the second example, x to the 1 divided by x squared, we have 1 minus 2 equals minus 1. And you can see that we end up with x to the minus 1. It's also important to note that 1 over something is that something to the power of minus 1. And we'll get to that in a second. But dividing terms with indices, we are going to subtract the denominator from the numerator when we're talking about the indices. When we have a look at something which contains two terms, which is what we're going to be looking at, we're going to be looking at moles, decimeters, and those are two separate things, we can't combine them. We have something along the lines of x and y. So simplifying that down, x and y squared, you can't simplify any further. If you have x and y squared, then what you're saying is that you're taking x times y squared, multiplying that by x again, and by y squared again. We can see that that goes to x squared y to the 4. So when we've got brackets, we are multiplying the indices in the brackets by the indices outside of the brackets. So the x multiplied by 2 becomes x squared, and the y squared multiplied, we see that the 2, the squared, the power it's raised to is multiplied by 2, that ends up with y to the 4. So hopefully that's nothing new. That's all going to be super important to us when we're thinking about units of Kc. Let's have a look at this particular Kc expression. This is an equilibrium of aqueous iodine and potassium iodide. That's the Kc expression. Let's have a look at the units of Kc. So all of these concentrations, they're going to be measured in moles per decimeters cubed. So you can see that we're going to have moles per decimeters cubed on the top, and then we're going to have the moles per decimeters cubed for the I2 multiplied by the moles per decimeters cubed for the I minus. So we're going to put them into a sum which looks like this. And we can cancel out here the moles per decimeters cubed there, which leaves us with this expression. We've got 1 over moles per decimeter cubed. Now, because it's 1 over, if you remember, 1 over x gives you x to the minus 1, which is why that if you look at the right hand side there, we've got moles to the minus 1 because we had 1 over moles. And you can see that decimeters to the minus 3, 1 over decimeters to the minus 3 has become just decimeters cubed. And we usually put the positive indices before the negative ones. So I've changed the order there. Decimeters cubed per mole would be the unit of this one. Yeah. So this example is an esterification. You can see that we've got an ester at the top being produced with water as a product as well, being produced from the reaction of a carboxylic acid and an alcohol. So if we take each of these 4 terms for concentration, and we put the unit in instead, we end up with moles per decimeter cubed times moles per decimeter cubed on the top and the bottom, and those all cancel out. Okay, so if they all cancel out, we can end up with Kc with no units at all. A slightly more complicated version now. We have the reaction of methane to produce ethine and hydrogen gas. You can see that this time we've got C2H2 is going to give us moles per decimeter cubed. The concentration of hydrogen has to be cubed, and the concentration of methane has to be squared. So we're going to end up with moles per decimeter cubed on the top, and we're going to end up with moles per decimeter cubed squared on the bottom. Okay, and basically in this case, what I'd do is I'd actually just write it out a little bit. If you're unsure, write it out in full, as you can see I have done on the right hand side there. So moles per decimeter cubed times moles per decimeter cubed is actually moles per decimeter cubed basically to the power of 4. And then you can see on the bottom it's squared. So if we cancel out, we end up having moles per decimeter cubed times moles per decimeter cubed left on the top. And so if we multiply moles and moles together, we get moles squared. And if we multiply decimeters cubed by decimeters cubed, because we're multiplying indices together, so we're going to add -3 to -3, which gives us -6. So moles squares decimeters to the -6 gives us our units. So there's really only 2 steps to this. It can be a bit complicated when you first see it, but basically all we're doing is we're inserting moles per decimeter cubed into the Kc expression. We're substituting that in for every single place that we see a square bracketed chemical, and we're not fiddling around with any of the indices that are already there. So if it's H2 cubed, we're just substituting the H2 for moles per decimeter cubed, and we're keeping the cubed there as well. And then we're going to expand it out and then cancel everything else down, and whatever is left, we're going to report that as the unit.